And as we go through the question, I hope to provide a visual model that we can use to show our students as well what is happening given the context. So first question, John had the same number of red and blue marbles. Right? This is a very important information. Red and blue marbles same. During the game, he lost 10 red and 36 blue marbles. And the ratio of the number of red to blue marbles became 3:1. Now I'm given the ratio 3:1. Let me just represent that using a bar model. So I have the ratio, this is quite okay, 3:1. Let me just draw like this, 3:1. I know I'm drawing the other way around, 1:3, right? Because I do this first. So the ratio of red is to blue is 3:1. Now, initially, John had the same number of red and blue marbles. And what had happened was that during the game, he lost 10 red marbles. So okay, there's a loss of 10 red marbles here. And initially, he had the same number of red and blue. Now the number of blue marbles lost was 36. So this is 36 here. Now what have I done? I have used a model to represent the entire context. What you see here, the bars, are the outcome, the after. Right? At the end, the ratio of red is to blue is 3 units is to 1 unit. Initially, the number of red and blues were the same. What had happened in between? He lost 10 red marbles, 36 blue marbles. Can you see that the difference here between 36 and 10 is the 2 bars here, right? So what can I write? 2 units will be represented by 36 minus 10, 26, right? Therefore, 1 unit is 13. 1 unit represents 13 marbles. How many red marbles did John have at first? Red is represented by 3 units. To find how many marbles John had initially, we take 3 units plus another 10. So red initial will then be 13 times 3 plus another 10, giving us 49. Right? So what is this? This is a mix of the unitary method using a bar model representation as well. You can see the before, you can see the after, you can see the change all within a single diagram. Right? Now, for those of you who have used the algebraic method, I suppose this is what you will have done. You would let x, our favorite letter x, be the original number of marbles, of red marbles. Right? So, what do? We may use what we have done just now, representing ratio as a fraction, right? Many of you did that, I saw. So x, after losing 10 red marbles, over x, after losing 36 blue marbles, this ratio became 3:1. Right? Red is to blue. You can write it as a fraction. Red is to blue. Is x minus 10 over x minus 36 equals to 3:1. So we have formed an algebraic, a linear fractional equation. All we have to do now is to solve for x. Okay, so solving x minus 10 equals to, you cross multiply, right? Most teachers love to use this cross multiply method. 3x minus 36 times 3 is 108. Right, then we solve for x. 2x would then be 98. X would then be 49, solve. This first question, algebraic method, is also very doable because we can let x be the original amount of red marbles. Solving for x gets us the answer. But over here, from the first line to the second line, what does this represent? Does this mean something meaningful? This is something challenging, right? What I'm doing here, what's happening here is just algorithm, just solving operations. It may not be as meaningful as a bar model here, right? Because every step, what the bar model represents, these are all very meaningful things that represent something. So for students who are unable to solve using the algebraic method,